Hey guys, welcome back to Hustler's Algorithm. Today we would be solving this problem rotate image, and let me just go through this problem statement so that we all will be on the same page. So you are given an n by n 2D matrix which is representing an image, and we have to rotate this image by 90 degrees in the clockwise direction, and you have to rotate this image in place, which means you have to modify the input 2D matrix directly, and we cannot allocate another 2D matrix and do this rotation. Okay, so what it basically says is we are given this 2D matrix, and what we have to do is we have to rotate this in 90 degrees in the clockwise direction. So if we rotate this like this, then the first row will be at the last column, right, which is 1 2 3, and then this second row will go to this second column, and the last row will go to this first column, right? Okay, so you can see this resultant matrix. So yeah, so let's see how we can solve this. And this is the input matrix, and we have to convert this into this kind of matrix, which will be a rotated matrix of this given input matrix. Let's denote it by IP, which is the input matrix, and this will be the output matrix, right? Okay, so let's think for a while what we can do. Okay, so let's solve this now. Now this is the input matrix which is given to us, and we know that for a matrix its transpose will look like this. Okay, so this will be the transpose. So let me draw this transpose first. Okay, now to find the transpose of the matrix, what we will do is this first row will become the first column in our transpose matrix. So this first row will be here, which is 1 2 3, and this is our first column. Now our second row will be our second column, so it will be 4 5 6. Now our last row will be here, which will be 7 8 and 9. Now this is our transpose matrix and this is our output matrix. So is there something similar? Okay, so we can see that this is just reverse matrix of this. Like if we place this last column here, which will be the first column, so then we will get this, which is the resultant matrix which we want. Like if we place something like 7 8 9, which is basically swapping this last column with our first column, then we will get something like 7 8 9 and 1 2 3 here. Now just shrink in the inside, and from here we will shrink on this right side, and now we have just this one column which will be placed as it is because it will be swapped with itself. Okay, so this is our resultant matrix which we want. Okay, now we know that when we find the transpose of this given matrix, this row number, which is first row, becomes the first column. Okay, so it will become the first column, and similarly this second row will become the second column, and this third row will become the third column, which means every element will be swapped. Like if the row and column is in this manner in the given input matrix, then this will become column and row in the transpose matrix. This is the transpose form, and this will be applicable for every element. So let's check this. Okay, so here the row is 0 and the column is 0. So if they swap with each other, we will still get 0 0, which is this first position, which is 0th row and 0th column. So for this two, what we have is we have this 0th row and the column will be first column. This is for this two. So if we swap this, then we will get something as first row and 0th column. So which is this position, which is the first row and 0th column. Great. Okay, so now we know that this 2 will be swapped to this position, but what will happen to this element? So let's check the coordinates of 4. So for 4 in the input matrix we have the first row and 0th column. So if we swap this, we will be having 0th row and first column, which will be the position where 2 lies initially. Okay, so we can see that we can simply swap this 2 with this 4, like the 0th and 1th element will be swapped with 1 and 0, and on generalizing we get that this row and column will be swapped with column and row. Okay, so we will get the transpose by doing this. Now we have our transpose matrix ready. In the second step, what we have to do is we have to convert this transpose matrix into our resultant matrix. And for this, what we have to do is we have to just swap these elements of this matrix in the column wise manner, like the first column will become the last column in this resultant matrix, and so on and so forth. So let's see how we can do this. So now instead of just considering this complete matrix, let me just consider this one row, which will be the first row. Now here we have 1, 4, 7 in our input matrix, and in the resultant matrix we have 7, 4, 1. Now instead of considering this complete matrix, if we consider this single row, which is an array itself, so we can see that the resultant of this array is simply reversing this given array, which is this given input matrix row. Okay, so we can do this for all the rows so that we can get our resultant matrix. Okay, this looks good. So now let's see how we can convert our logic into code. Now I'll start by creating a function which will create the transpose of this given matrix. Okay, so this will be a void function because this will not return anything. It will just transpose this matrix. So let's feed our input matrix. Let's name it as mat for simplicity. Okay, so to get the transpose of the matrix, what we will do is we will just swap this row column with the column row as we saw here. Okay, so let's write this. So first we will maintain the row length, which will be the mat dot length. This will be our column length. Okay, so we will just write a loop for traversing the rows. So here I will be the rows and we will traverse till the end, just I plus plus, and we will write another loop for looping through our columns, and we will start it from I and we will traverse j while we have some columns left. Okay, so let's do j plus plus here. Okay, so here we can just simply swap this row with column. Okay, so this is the simple swap logic for just swapping this row column with column row. So let's call it. So we will transpose this matrix. So now our matrix is transposed, and in the second step what we are doing is we are taking this complete row one by one from this matrix and we are reversing this. Okay, so let's see how we can do this. So let's traverse through all the rows. Let's define these rows here. Okay, so we have these rows here, and now this is an array which will be our row, and this will be matrix of I. So this simply says that we have our row which is at this ith position. Okay, so let's just reverse it. Now for reversing the array, I can just maintain two pointers. Let's say the first pointer is L, which is at 0, and the R pointer is array.length. So it will be at array.length, which will be at the last position. So we'll just quickly subtract 1 from here so that it points to the last index. Now, while there are elements between this left and right index, we'll just swap this. Okay, so while there are some elements between these two pointers, we will just swap this. So let's maintain a temp pointer which will have the element at L. Now this element at L can be overwritten as element of R. Now this R can be assigned the element which is at temp. Okay, so once we do this, we can just increase our left pointer and just reduce our right pointer by 1. Okay, so this will do our work, and we can just return our matrix. Okay, so let's try to run this. So what's the error? Okay, so we do not have to return anything, my bad. Okay, so let's run this again. So yeah, it gets accepted. Let's try to submit this. Okay, so it gets accepted. Thanks for watching and subscribe to the channel for more such content on data structures and algorithms. You can follow our Instagram page which is named as Hustlers Algorithm. So thanks for watching. See you in the next video.